streaming. Okay. Gravity's attraction. Yes. Come on, get it. It looks like this on the very first page. Potential energy. And, oh, hold it. I was talking and showing you things, and nobody can see it. Looks like that on the first page. It's right there. Right there. Got it. Yep. Okay. You were here.
I know, but I
Right there, right there. Not that one. Over.
I organized my binder, but in the end.
Okay, there you go. You got it. Okay. Gravity's attraction, as you may know from being near a planet, you don't have to go that far away from Earth to actually experience pretty low gravity. Gravity's attraction becomes the weakest the farther I am just waiting because there's a lot of conversations not about what my writing is. Yes, you don't even have to ask. Elena, Savannah? It is the weakest, which is probably my worst written word today. The weakest, the farther. Okay, that one was wrong. Two objects are apart. One of the ways of visualizing this, I have in this diagram down here. Gravity can be assumed to be coming from the center. The force acts that way. We're just sort of stuck on the surface, but as long as you're any distance from the surface, you experience it like it goes to a point. If you take that particular area and you say that this is distance r, then you wouldn't go distance 2r, then that area spreads out to 4 times its original amount. And if you go again, so just one more distance, it spreads out to 3 times. And you can see this with this two-dimensional drawing that attempts to show you a three-dimensional construct. So gravity gets really weak really quickly, but it also spreads throughout the entire universe. So there is nowhere that doesn't feel any gravity, but it gets very weak very fast. So we only experience it when we're really close to something, like a planet or a black hole or a sun. And what is our nearest and largest mass? Earth. The sun will do a little bit. It will affect the tides. It doesn't provide the opposite tide, but it does, in fact, do a little bit. But even it, as large as the sun is, keeps the planet going around. We don't feel it. If we're facing the sun, it's not like we feel more or less gravity than we do. Earth is the strongest one. Hold it. I got a blank one here. 2 objects are apart, so we really only experience... That actually doesn't even seem to need there. We really only experience strong gravitational attraction towards the nearest node. Yeah, I'm just going to cross that out. That's silly. Acceleration of gravity. Oh, I know what that was supposed to be. Sorry. We really only experience 1 strong gravitational attraction. This is for students who, when I'm asking you to calculate something, worry about where Mars is. You don't have to worry about Mars is or what its gravitational pull will be. Wile E. Coyote, 9.81, written below him, is the gravitational acceleration due to gravity on planet Earth. That is an average. It varies from 9.74 to 9.86, I think. We tend to use 9.81. You may see some textbooks use 9.80. That value is used as an average no matter where you are, and was calculated in like 1851. And it's just used in high school physics classes. If you need an actual one, you would just measure the local amount if you were doing an actual, like, something you needed a lot of precision for. All objects with mass are attracted downwards toward the center. We think now that if you have antimatter, that it is still generates the same gravity, but there is some physicists who suggest that antimatter could actually have the opposite effect. So gravity would affect it in a way that would push everything away from it. But we've made enough antimatter now that we think we've managed to measure it, but it's really on the edge of our significant figures of what we can measure. Antimatter is actually made in particle accelerators. Like we make like whole fractions of a gram. This causes all objects to accelerate at 9.81 meters per second squared. This is a constant, and you can assume this for all of your problems. Well, not emotional ones, but physics ones. Now, whatever we saw the video with the bowling ball and the feathers, the acceleration of gravity does not depend on weight or mass. So it doesn't matter how much mass something is. Everything falls at the same rate. There is air resistance. So if we walk out of the lab and we drop a feather, of course it's going to fall slower, but that's because there's another force acting on it. It has to push its way through all of the air, and it needs some extra force to do that. Mass does help with that. But if we manage to suck the mass out of the room, so if we use large blocks and the air resistance isn't going to be as much of a problem, we're not going to notice it too much. We do notice it with creatures, though. If you drop a horse down a well, the horse will go splat. However, you take a mouse and drop it from any height on the planet, they will survive. Due to air friction, the terminal velocity of most mice is such that they will never hit the point that they will die if they hit the ground. They will just bounce and then run away. So if you get small enough, air resistance can help you out quite a bit. Oh, I put that on the... Also, in a vacuum, they both land at the same time, and then they both would go splat. The height of an object above the Earth's surface determines its potential energy. Is that the old time? Well, yeah, everybody leaves. On a regatta day, you know, that would almost be fair enough. The greater the height, the more potential energy. And the reason it has more potential energy is that gravity is acting on it for a longer time. So you just have longer for it to accelerate and accelerate and accelerate and eventually hit whatever it is it's going to hit. This is why shooting guns in the air is so dangerous. Those bullets do have to come back down, and they are small and heavy, and they can hit almost with the same amount of force sometimes as the gun, depending on the gun. What is the unit of height? Meters. In science, it is meters. We don't use freedom units here. And even in science, the freedom sciences also use meters. So if we were to look at these, which piano would you want to be dropped on you? Probably neither. But this is going to hit with significant more force, being dropped from 10 meters. 10 meters? That's like a few stories. Okay. Calculating potential energy. Let's get some actual calculations. We have our formula. Energy of potential, or you could write potential energy, doesn't matter, is equal to the mass times the acceleration due to gravity and the height. M is the mass. What do the units of mass always have to be in? Kilograms. G is the acceleration in meters per second squared. We will, if I don't give it to you, like I don't say, like if I could give you a question, we're on Mars and the acceleration due to gravity is this, you can calculate it there. But for planet Earth, we will always assume 9.81 meters per second squared. H is the height in meters. And PE is the potential energy in joules, which is a kilogram meter squared per second squared. If we put our units in, we will have some amount of kilograms. We will have meters per second squared times meters, which gives us our kilogram meters squared per second squared. So you can see whether we're talking about kinetic energy with 1/2 mv squared. That was our kinetic energy formula. That gives us the same units as this particular formula. If you can take variables and multiply them around and get those units, you have found a new formula for energy. That is how sometimes scientists have gotten insight. Hey, maybe if we look at this in this way and how these interact, maybe this is also energy because they get the same units. So on Earth, the acceleration of gravity is constant. Your textbooks and stuff will probably say that it never changes, and you can just assume that. They lie a little bit. There's slight differences from here and around. But we will assume that. Also, unlike mv squared, it changes linearly with height. So whereas before, the faster you're going, even more energy was given out. Twice the height is just twice the energy. So you have double the height. Has double the potential energy. And half the height. Has half the potential energy, and so on and so forth. Right. Too fast. Too fast, Mr. Neufeld. Class has started again. And it's over again. Does it always beep twice like that?
Yeah.
Okay, let's take a look at this diagram. I don't know what this height is. It's not exactly a meter, because if it was, this would be 9.80 joules, but it must be close to that. However, if you're on the ground, how much potential energy do you have? None. You got 0. And at this amount, whatever this is, you have 10. So if you go up another amount, you would have 20. If you go up the same amount, you'd have 30. And you go up this amount, you'd have 40. And then you drop it from the top, and it's on the bottom. How much would it have? 0. It would have had to give up that energy on the ground. It would have accelerated. It would have hit the ground. All of that energy would have turned into sound, maybe light. and then just crunching whatever's on the bottom, and it would dissipate. This is why like bike helmets are so important. If you have a certain amount of energy from 1/2 mv squared, all of that energy has to go somewhere. And if it goes and you have a bare head, then it goes into your skull. But if you have a helmet, then it goes into the helmet and it breaks the helmet apart. I saw a wonderful little TikTok video of a gentleman showing how good their bike helmets were. They took regular bike helmets and they improved them. And he would take a baseball bat and he would hit traditional helmets and they'd smash apart. And then he'd hit his helmet and it didn't break at all. It was fine. What's the problem with that helmet? Yes?
It's too hard.
It's too hard.
The bike helmets are designed to break.
And if it didn't break, where's that force going to go? Right into your head. In the first... Has anybody here not seen the first Iron Man movie? You have homework now. You must see immediately the first Iron Man movie before next class. You want to go back up a little bit? First Iron Man movie, he takes off, spoilers, and lands in the very beginning in basically his entire suit. And then because he has a suit on in movie tropes, obviously he's protected. Except that's so much worse. I mean, if he had landed just his body in soft sand, he's actually somewhat protected. But if he hits and he's inside an iron suit, that might be worse depending on how the suit hits the sand. And so it definitely doesn't protect you in any way. You want things to crumple. Modern cars, when they're hit, are just destroyed in the process because they're designed to crumple and then crumple around the driver. Old cars, they hit, and the car actually comes out fine. You can throw away the driver, but the car just needs a repair or two, and it will keep going. They're made quite solidly so that they don't crumple, so the energy only goes into the driver. Good, sorry. Okay, school. Okay. It also changes linearly with what? So it changes linearly with the height. What else does it change linearly with? If we wanted to double the energy, what else could we double? The height. We already did that. The mass. We can't change gravity. If you do manage to invent something that can change the gravity on the planet, that would be huge. You could lift up planes, rockets, everything without actually having to accelerate them. It'd be worth a lot of money. You do need to be careful, as I mentioned before. Someone will take advantage of you, probably steal your design, so you should probably bring it to me. And then I will take care of you. Oops. Let's not do half. Let's say triple. Fill in the diagram below. If this particular mass is 25 joules, what does that one have?
I have a question. So
Yeah.
If they're like the same level, but one has more weight than the other.
This one right here.
Yeah.
Yeah.
Like double
So if it did, and this one was 25, what would that joules be? 50. Yeah. Well done. And if we took that 25 and we put it up one level, what would that one have? 50. And then if this one's 3 kilograms, this potential energy would be 150. What's this one again? That's 4 kilograms right on the bottom? 0. It's on the bottom at 0. Now, for this first practice, I'm going to start you off. Mass equals, height equals, what does gravity equal? And then put down your unknown. Get in groups of 2 or 3. Grab a marker, go to a board, show me your lovely work, and put in all of your units. And for this one, I would like you to put it in scientific notation.
Can we erase? Or no?
Yes, erase. Erase, erase.
Mass is 16 squared miles. The height I thought
No. I already told you about the program. Those are not safety goggles.
Oh, they can be.
Hit her in the eye. Put it in scientific notation. Portia, join the group. When you're done the first one, you can do the other one right beside it and show it to me. What do we got? Are you ready to run for me?
Yes.
Excellent. Well done. What do we got for our first one? Times 10 to the 5. Excellent. Okay. Oh, units go at the end. This is a matter of convention. We just put them there. No, because you have to put a scientific notation. And where? Come on. got it? However, also correct sig figs.
I'd say like point.
Two sig figs would be right. And it's not, that's three sig figs. And it needs to be size rotation. And it needs to do this.
So it's like this.
Oh,
But then you have all the other numbers. Now you have
Oh no, that's adding sig figs without the number. Good job. Here, let me give you a little sig fig.
that was right.
So like, if you have like a number like 5,926, if you put that in size rotation, you want two sig figs, 5.9 times 10 to the 3. If you wanted one sig fig, it would be 6. 1, 2, 3. That's 5.93 times 10 to the 3. You don't add, if you add zeros, like if I went 6.0, that's two sig figs. You don't add zeros. If you go this way, you get rid of them because they're not important. This does it like, does it that?
Ask your father. Mr. Neufeld.
No, this makes sense.
Are we right?
Really?
You think we're right? Or it could be, or it could be.
Yeah, it is zero. But what we're saying is that this
Oh, wait, I
is
should.
5.9 times 10 to the 3, because that's really just 5, this was 5,926, right? But if this is plus or minus on those, those zeros don't matter. Right? It's plus or minus 100. So how do I show that? In sign notation, I can just stop at the 9 or plus or minus, because those numbers don't matter. I just drop it.
Okay. Yeah, that's in the second.
Yep, 2.5 times 10 to the 11. Okay, let's get rid of the diagram.
No, we need the
And
diagram.
then just delete it.
No, you don't. No, we don't.
No, that's what you say.
You don't need.
And then we'll just, that's the formula, like make a line. Energy.
I relate to this.
The same thing with just J. Yeah, there you go. Good. Lunch doesn't even open before. Tell you what, you'll be out. What? But I don't need it. I don't need it from you. I need it from your close parents. As soon as you're done. So your mom is totally willing to wait. Thank you for confirming. I do the second question if you're doing the first one. I am going to write on the answers. Is this done? Ah, found it. So you should have got for this one 2.5 times 10 to the 5 joules. For this one, you should get 6.36 joules. Start with the second one. And show them to me. And then if you do all four, I have a prize.
Is that like the
Yeah. 3, 6, 2, 7, 6.
What do we got?
0.00?
And that one has a I was going to say a snake, but now I think it's a duck. It's a drake? It's drake. Isn't a drake just a male duck? So it is drake. It's sort of a snaky drake.
Le preguntó de lo que hizo Sebas. We just finished
Excellent. How many, first, for that first one, you need the correct number of sig figs. How many sig figs should we go?
Oh. The first one, where's the sheet? What does...
You can go right through your numbers you've written down right here. What's the smallest number of sig figs you got, Elise? 3. That's 3. That's 3. That's how much? 2. So this one should be the 2. Bring it down to 2 sig figs. Now units. Now units go here. Besides everything outside there.
So, but that one's space.
But that's not the units. You got kilograms, meters times meters per second squared. What would that unit be? You're missing units. Oh, kilograms. And then what is a kilogram meter squared per second squared? Joules. It's a joule.
O sea, fuera de lo normal. O sea, nunca lo he hecho yo.
Score.
Times 10 to the 5.
Sure.
So my foot.
So, Manuel, Elena, I need to see all of them. You've done the first 2. Show them to me. Start on the next one. Flip the page. And then come see me for a special prize. Which one's yours? That one there? Okay, the top one, you need units and sig figs corrected. The bottom one, you also need units and sig figs, but the numbers look good. And then if you flip the page, you got 2 more questions.
I'll do you after this.
Okay, first one looks good. Units need to be on the other side of the times 10 to the. They go on the very end. Units go on the other side. Right? This is times 10 to the 5. The units go on the other side of the
10 to the power of 5 units.
kilogram. You've also lost a unit. You lost your kilogram. Yeah. And then, what is a kilogram meter squared per second squared? What's the unit of energy? It's a joule. So you just convert it to joules at the very end. And then significant things. That's again the right number, but you just need the right units. Got it? That looks good. Yes, you can erase that one. And the other one is not good. You got right units in both. Start the next 2 questions.
Is our second one good?
Call me over when you're good to go, and then start on the next 2 questions.
And we're
Yeah.
1, 2, 3. Okay, let's get the wrong.
Good. Now, flip the page over. You got 2 more questions.
All done with
You've got.
Here, I'm gonna write this in my.
Let me come around. Show me. Point 2. Point. Which one's yours? Go stand up. Okay. So for this one, you don't have your final units. You dropped a kilogram somewhere. And what is that? You have 2 meters, so you got meters squared per second squared. So a kilogram meter squared per second squared. What unit is that? Joules. So your final answer should be joules. How many sig figs should this be to? How many sig figs is this number? 3. How much is that number? How much is that number? So this should be to how many sig figs? Well, that one was 2. So you should have 2. And then, there you go. So just fix the units, and then this one sig figs as well. And then other than that, because your numbers are good. Both of yours were good. Yeah. So erase them and do the next one. That one looks good. That one looks good. So whose area was this? Excellent. Now just do the next one.
Okay, next one.
Yeah. Oh, you can though. There are people who are sticklers. They would say, "Oh, put that in scientific notation."
10 to the power of 0.
Nice.
I look so sorry.
6.36 times 10 to the 0. There's no form at all. It's just there to make it look more scary.
What's our test?
When? We gotta do lab first. Lab hopefully next week.
What's our test?
Tuesday? Monday? Is it Monday?
Tuesday.
What?
No, it's Tuesday, because today's Friday.
Friday, and then we have the other class on Saturday. We have that class on Monday. But unless sometimes they move the schedule around, they can class over here. So I just do what my school tells me.
What's our lab? Are we going to?
You're gonna take carts? iPad?
energy
No.
divided
It's like go in them and
No.
gravity and height.
But
This is a
now
complete
you've done these.
No, meters per second, and then we multiply and
Me, I have one.
pass it to.
Because then I could like
Oh, that's
drive
so
it.
far.
Write those down. So write them down and then do these ones. And once you're done, I have a prize.
Study prize. They see me going through like yellow.
The next two questions.
But I was like, right now.
Yep. Yeah, you're good. Now once you put the units in, you're good to go. Erase. Do the next two questions.
Oh, the blue one, bro. The blue one because or transfer.
Did we only put Jules in this time? Hey guys, write it down.
Oh, I should figure out where am I at.
Or we buy the blue one and we I buy one for you, one for me. And we were like, if you want to, double check it. You're gonna take that for real.
Then you just finish up your lunch with your mom because you'll be all done. Well, no, you have to leave. It'd be really sad if I had to give your phone to your hostess as opposed to giving it back to you. Whoa.
I like the purple.
We're ready. Why is your phone out?
No,
Oh, it's face. Also, you should probably drop it in the notes. So this is going to be a math question. This is a height question. So you can either put the formula and just solve, or you can get the formula to mass equal and height equal. Not if we give you the energy. Algebra. But you seem to have left Portia over here. Portia, cozy up. Cozy up, Portia. And Daniel gets to go to lunch with mom. Beautiful. The example published before.
we buy the house.
What do we got? This is the math one?
Gravity and mass.
Oh, it's the one I got. Where's the
I thought you were telling me that this was wrong. I'm like, no,
No, it just confused me.
So not what I got.
Technical energy.
Let me go double check. Let me double check the question. Da, da, da. 6 point. Potential energy at 4.4 times 5 joules. How high is it soaring? Yeah, I got, okay. Yes, excellent. And I say excellent because also you confirmed I was right. They convinced me I was wrong.
we did not convince
You
you.
convinced
You just walked
me.
over and said, I
I'm
think
like,
I'm wrong.
well, I thought you were. It was so much different from mine. I thought maybe I wrote something down wrong. Okay. So for the first one, I get something around like 700. So height equals
You're in my seat, you
potential
little
energy
freak.
less than the gravity, 9.8 divided by question. Make sure your 6.2
kilograms.
Yes, that looks good. Show me how you punch that into your calculator. No, you should use it anywhere you want. Show me how you punch it into your calculator. I mean, come around and watch.
Okay.
En business no vaya no solo proyecto. O sea, sí, pero no tiramos por ahí.
Oh God, don't do that. 4.4. That button is times 10.
Okay.
And the reason for that is you have to use a lot more brackets than you have to put brackets around the whole thing, because otherwise your computer just treats it as another part of BODMAS and may move them around. And so you go times 10 to the fifth. Yeah, okay, now keep going. Equals, divided by, or
No,
whatever.
no sé,
You're
vamos
on
a tratar.
Did you subtract the... Stop!
Y nos dijo que el examen no va a estar difícil.
Oh, I don't have it done, but you do this, you do the scientific notation, and you
How do you 3/8?
And this is the
divide
medium,
that,
right?
that, it gets some height, and then divide that into scientific
Right.
notation.
How do you 3,800?
Where, would you get that?
Okay.
The,
Sometimes they get as a cognitive dissonance as well. So I've got
oh, you
energy
know,
potential is
That's
equal
all.
to
And then Miguelín.
well, no, it's,
I'm on
H. So H is equal to 1 G
oh, I
potential.
erased it, but this is the answer.
And
No,
you've
number
got
3.
Yeah.
Number 3 is math. Yeah.
No, we have the mass, it's 6.21 kilograms.
Yeah, but you have 2.7 and I have 7.2, so I am just double checking. So you've got that many joules. Where's the paper?
I don't know.
Is this not, what is the next up?
And then
Is that height?
4.4 times 10 to the 5. 9.8.
I'm really gonna take that
Should be gravity. Second square. Got that. I saw you into that. 6.21 kilograms. Yeah, no, that should make sense. Yours is right. So you took, work with this, divide by this. You took that and divided by 6.21.
No.
And then you did 6. And I just watched them into those calculations. I'm sorry, I'm thinking. The first is good. And the second one, seems a bit big to me. Yep. I get 87. I think that's right.
¿Recuerdas ayer?
Double check your calculation.
De la, dice que la fricción.
Times 10 to
No
the
le tenemos que hacer como la gravedad.
Oh, you give you a prize.
Dice que la gravedad.
Is it another worksheet?
No. Might be another worksheet. Oh, look, it's another worksheet.
Wow. That's so fun.
Yes. Excellent. Oh, no, I have a task for the two of you. Go over there. As far as I can tell, everything they did was
I tried
right.
it on another calculator and it's the same thing.
And they still keep getting it wrong, and I don't know why. Find out their mistake.
Yeah, but he just went over it and he can't find what we're doing wrong.
So it's scientific notation, and one scientific notation. That's not scientific, but the number's right, and that's also scientific notation. Yeah, how many sig should it go to? Yeah, that's right. But no. But how many sig should this go to? It's and this one's 2.
You erased one.
But numbers are good. What time is the class ending? 11:25.
What did you say? What did you say? Oh, did you?
Are you asking about sig figs or scientific notation? So sig figs, you go back to the original one. Which one has the smallest amount of sig figs? Yeah, so it is 2, so your answer means 2 sig figs. Yep.
Like the 17,000.
Your prize.
So what was wrong? We weren't putting brackets in.
Oh.
Was it just a calculator error?
Yeah, we just weren't putting brackets in.
So in traditional modeling, what you made was called a calculator mistake, which means if this was a 6-mark question, you know, writing it out, putting all your units in, you get half a mark more. Your method is entirely I don't know a lot about how to use a calculator, but that is something even in Chem 11 that messes them up. You know, like a calculator, put brackets in, just to make sure. And that, oh, and your special prize. Your special prize. Your special prize is nothing.
More math!
More math. Let's go.
That's what I said.
Tell me what- Yes, that is correct. And
Oh,
yes,
wait.
that. I think you have the sig figs backwards. Oops, oh, I'm sorry. Yes.
Wait, what do you mean?
And yes, except way too many zeros. So, yes. 3. That's 4. But that number only has 2. That number has only 2. Yes. Power of 2? That would only be power of 1. Yeah. Yes, you may. Yay.
Dr. Duval.
Yeah, hey, doctor.
Okay, so over here, I did it really wrong, but it worked. I think.
You're out by a factor of 10. That might be a calculator error. Equals 6 point, how did you get 3? Oh, you multiply that one by the other side. Yeah, no, you did it right. What are you talking about? Yeah. However, and then when you got it, you had your 8 on the other side, and then you flipped it to the other side and divided the other one. That's fine. I think what has happened, and what happened with a few other people, is when you do your times 10 to that, you can get out by a factor of 10 if you're not using like the right buttons on your calculator. You're not using the right brackets. So I would double check your calculation because it should be 7.2 times 10 to the 3. And your times 10 to the 2. But other than that, I would check that. It looks good. Clearly the numbers are going through right. Yes, bro. 7.22 times 10 to the 3. Yes. You need units. It's in meters, but other than that, it's good. Your second one is not in meters. It is mass, and so you also need it. But it is the right number. Also, for both of them, how many sig figs? So here's the question.
3 was. Oh, I guess it was 4.4.
4.4, so it's 2, and the other one is 3,800, which is also 2. So it tricks you in both ways. But other than that, yeah, 3,800.
Oh.
Yeah.
Did we get it right though?
Yeah, you got the numbers right. So would you like worksheet? Your special prize? Who does not have the worksheet yet? There.
Which one is it?
This is on the stuff we did just now.
Oh, yeah.
And the, if you can make it out on the left, that is the amount of calculations that was on a board. You already have one. To solve one kinetics problem at a university level. Put your phone away. The last thing on the notes is where you don't have to fill anything in. Essentially, if for some reason you can tell someone who wasn't here today, this summarizes everything you need to know about calculating potential energy. It gives you an example problem. All the numbers are there. All the units are there. And theoretically, the sig figs should be correct. So that's all that page is for. We don't go over it, but it's there in case you're reviewing and you need a good page with all the things. People who were not here last day and need the scientific notation worksheet, come on up. Who was not here last day and needs scientific notation? It was Luke. Elena?
Yeah.
Come on up.
Oh, I was here.
Not you.
No, other Elena. Yeah. So, this has a practice just there and there that I can do. The answers are also on the live stream. Though, to be honest, I don't know if I think the live stream failed on that particular day. So I'll just quickly show you how to do it. And then the second one's just a worksheet on how to do scientific notation. Is there anybody here who's like, I know exactly how to do scientific notation, I don't need anything? Was that like maybe or like I'm good to go?
I'm good.
You do it in math something. Good to go?
Yeah, is
Good
it
to
for
go?
homework?
Yeah, homework. It was due today.
Okay.
But for you, it will obviously be due next day. Oh, did I not? There you go. Anybody else not have the worksheet? That one. The height one? Working something? Yep. That's Mr. Crowley's personal seal. I don't play with that.
Huh? Nope.
That came out in the future. I'm sorry. No, doesn't mean you're going to that. Means you can become incorruptible, renewable. Yeah. Or good. Because someone who believes that they're absolutely good. that you know that it's possible, you don't want to do it, but also there's a part of you that thinks you should.
Okay.
Like, I should do this, this would be like best for everyone. So current, a wand
Tengo ese que es la verdad.
is like an energy pump.
Do you want those worksheets?
Oh yeah, I thought I gave one to everybody. They came up. Yeah. Does anybody else not have a worksheet? In this particular one, sorry, this is sort of subtle in terms of this is like being at the bottom of the hill. You have given up a lot of energy, you've accomplished a lot of things. Not farther in your journey, but you're going to need to put more energy into those things. Everything is kind of on its settled phase. Actually, this is a pretty good spot to leave. In the past, the Prince of Cups made a lot of change. The Prince of Cups would kind of indicate you were in charge of a lot of the change, and you made it happen.
Yeah, we're at
And it transformed from
oh yeah, alright, I social
flowing, stirred sort of change that you initiated to now it's settled, calm. But in a position to do something else. You keep going, later,
I'm not asking you.
there is a large conflict in your
Okay, so when 135.
This doesn't say it's better. It also doesn't say it's good. Just that it's going to happen. And you're going to do it. You're in charge, much in the way you were in charge. So you have an obstacle to overcome. This doesn't say that at all, it's just that you should be prepared. If you make change that, you know, maybe I should do this. I don't want to, I don't think it's right, but like, this would be best for everyone. That, as the card says,
Yeah,
most people would recommend to go do that, but it also doesn't really say who's going to be disappointed. It could not be you. So it's not necessarily a bad card. Often it is interpreted as being you, but it doesn't have to. There's more possibilities than just the one. And as it's a cups card, it's a little chaotic as to where that disappointment is ending up. But there is a lot of disappointment. It is more centered on you. It's just making everybody disappointed. You might be fine with that. So it's hard to tell this one without, like, if it's a center card, I would look at these two to interpret it. But with this one, I can't tell which one it is. For this one, this would mean that you, now this is if you don't do things the way you have, try and do something else. This would be a long term in the future. So this might even be beyond that. You would have to do something about the change. But it's kind of the thing that you do, you get a little afraid to make a decision. And you think, I'm going to, you decide to change path and you do something different. The mage is accomplished in its craft, knows what they're doing, has a goal, but there's also use of level. There's a bit of love in there, which is nice.
Okay.
Mischievous, doing things for the fun of it, and maybe causing a little bit of chaos. Political dissidents would have a lot of this kind of thing. But also, this shows as an area of leadership as well. So it's not just, although it's presented as a load, it is not just a load. But it's also disruptive. So you have had to do a lot to get here. You change the way things work around you, and now you have a lot more controls the wrong word, because you didn't get here by controlling everything. You got here by maybe nudging things along different paths so that it just happened to agree. It's a Did it make sense?
Yeah.
Good.
Do you know any other spreads?
Oh, there are a lot more complex spreads.
Yeah.
There's one where I can do one past, present, future, but also like emotional health, physical health, future, past. Ones where it can just look at what's going on right now, and you can divide it up into like friendships, family. I haven't done this for a while, and so my ability to link the cards together isn't as good. So I find the simpler one easier.
Está bien, pero.
Just to warn you again, this is the Alistair Crowley deck. It was not actually drawn by him, so I'm playing music and I love the
I
art.
know.
However,
I personally.
there are people who hear his name and shudder. It is apparently true that his acolytes at the time, 18th century, early 19th century, I came to him and said, can we have like the secret of everything that you know? Because he had said that he could like, say it in a sentence. And he's like, yeah, pay me $20,000. And this is like a huge amount of money. I don't actually know if it was $20,000. Kind of made it up. But they scraped and scraped and scraped. After 5 years, all his acolytes gave him the money. And after he did so, he whispered in there, there's a sucker born over there. It's just the kind of man he was. And, this is important, I feel, they didn't leave.
That's really funny.
They thought it was very wise.
Oh.
And in one sense, it probably is. If you didn't know that lesson before you, it's a very valuable lesson to know.
I would not pay for that lesson.
It's like my uncle, who was a police officer in Vancouver. He said he never gave up tickets. He gave out driving lessons that they paid a fee for. Okay, you get religious. I'm the Prince of Swords. I am going to think there's something going on with the entire cult.
Did you get it?
Yeah, all three of them.
Every person has so far has gotten
Wait a second.
That's the height. Mr. Devo, to find the potential energy, it's pandas the other way.
It's
Pandas like the other way when you're solving the equation.
Penda?
Penman.
Pedmas.
Yeah.
Oh, it's always the same?
Forgetting to read.
I think it's the
You
other
just follow normal math rules, whatever you learned it. Sonny? Oh,
I'm actually looking something like that.
You didn't ask me I could do that, Patron. I thought you
So I didn't use I got it.
well, then bring out your notes. And you have one formula, start doing some practice problems, bring it to me if you
Yeah,
have any
because he
problems.
did his class.
It'll be all good. Oh my goodness. I'm so sorry. Oh, interesting. That one is good as well. Oh my goodness. That is, just so you know, that's not It says fortune and it implies luck, but that luck always comes with it from the help of others and your own hard work. So you had to have been lucky to get where you want to go. However, it would not have come about without the intervention of others and yourself. So it is extremely fortunate to be in this position. There's a great deal of celebration right here and right now. This is what you have to overcome a significant amount of adversity to get. So this is in your hands. But there's something significant that happened for you to overcome either. And I can't tell because I haven't done it all already.
Oh, the one that
This
has
is
like the
internal
camera of our
or
phone?
external that happens enough or just you personally and getting into it. But you really struggled to get through this. And then continuing on as you have, this is an area of calm, and this would be like after the roller coaster ride, like much like we discussed. Once you're in motion, and you can just keep doing things that you're doing. It's like a far future, so this is a relatively soon future, like next couple of years. Things will go well, and you just need to keep doing what you're doing to focus on what you're doing. These are fast. No, you have a question?
Yeah, so for this part, it says there's like 2.5. Do we replace that from 9.81? Finding the maps, so it says.
So measures the velocity of the ball at 2.5 meters at the bottom of the ramp.
So is that we use that?
You may, you have to use the 1.5 MV scale. So you have the bottom of the ramp with the kinetic energy. You might have to use both.
How do you use both? Do you like times?
I don't want to say no because there are ways that you can do it.
You add them?
Take a look at the question and see what you can fill in. You're completely done? You want to have your names on it? You're good to go? Okay. The Hangman does not mean that, but it does mean great personal sacrifice to bring about a change that you want. So this implies there's a course of action. Now, how this is divided, this is on your right. This is the thing that you think you probably should do. You might do. This is might be a good thing you've been thinking about. Maybe I should do this, maybe I wouldn't. This is a potential future for a different goal that you have. This is the one that you think that other people should do, but you're not going to. But you think, well, maybe this might be. If you pick that particular goal, this implies a lot of sacrifice. To achieve something that it means almost a total transformation.
What's the original?
This is called the serene future ordinary day. This is
Go for it.
implies
I mean, I would like.
into account a lot of turbulent change that would have to happen that you would actually have to do. But to achieve a specific something that you've been thinking about wanting to do. This implies that you could do different from what you're doing now. But there is something that you want to achieve that you haven't really done yet. And you may not, you just keep going, you're probably not going to do it, but you made the decision to do it. Maybe it's possible. Does that make sense?
So apparently I wrote
I don't know what it is, but this means something significant. Not like just deeply personal. This could be, this could be everything from something very simple. Also, could just be through trial and tribulation. For some students, leaving home for the first time was really hard. So this could be, like this isn't like everybody has to die, but a very significant challenge. I don't know.
I'm just gonna take a picture of this.
Oh no, no pictures allowed. No, not on the Crowley desk. No. Oh no. I don't want parents coming back later. What kind of future did you tell my son? Questions?
For this one, I calculated it all together and I got 2,884.14.
Yeah.
But the smallest amount of cyclic least amount of sig figs is 3, am I wrong?
Oh, hi, I
Wasn't there a time for, oh, at least on 6 figs.
But like,
Oh, but 4 seconds, it's 100 total, so that's 4, okay, so the smallest number, that's 120.0, so that's 4, 3, and 3.
yeah, so then the smallest amount would be 3.
Yeah,
So
yeah.
then I don't round up. I leave it as 2.88 because it's 3 sig figs.
Yeah, 2.880.
So it's not 2.9.
Not 2.9, right.
Guys,
What
It's
purpose
not
is
2.9.
it?
For the first one. You don't round up because the least amount of sig figs is 3. It's 2.9.
So, who, did you want another one?
I did want another one for my clarifying for what I could change.
Oh, I feel like it all, you know how I do this.
Also, I got one.
How? Pardon?
I got one question. How come you like shuffled the cards longer for me?
Yeah.
And also you just picked the cards for me instead of just telling me when to say what. Like,
Oh,
give
did
me-
I not say so right?
No.
Oh, I didn't even think. That apparently was just the ways of the universe at that moment. Apparently you weren't allowed to pick your own fate.
Oh, God. Dang it.
That would indicate you're feeling trapped right now.
Mr. Neufeld, I have a question.
Yes?
For example, like on a test or on a quiz, if we put once we find the potential energy of something and we don't put the least amount of sig figs, are you gonna mark that as wrong or half a point?
I'm gonna look at, so I don't mark individual questions as a proficiency. I correct the question, like, oh, sig figs, this, this, and this. And then I look at all of your questions. Can you do it on your own? Proficient. Did you do it on your own and made basically 0 mistakes? Extending. Were you unable to do it on your own, but you could have with some hints? So like, are you always getting the sig figs wrong? Or you're always getting it wrong? Some version of it wrong. Oh, yes. Thank you.
Thank you.
Thank you. Sorry, Sergeant and tutorial. A reminder to your houses will always right now be on lockdown. Enter through the correct entrance. Thank you all. I have to get better. I have to practice. Yeah. You know what I need to do? I need to make a YouTube channel and just practice.
Bro, that's too accurate. That's too accurate.
It is. Now keep in mind, I do, since I'm a science student, I do have to confess, the entire usefulness is in your own head. Because I'm just making up words.
I think that's like exhibit A that you did.
And then you're applying them to very real things that you make come true.
Yo, you guys should do this. You should.
Yeah. Well, I've got to be able to see the connections. And the more cards there are, the more complex it is to draw those connections. Yeah.
Thank you.
You're welcome. You're welcome.
Thank you.
Bye-bye.
Homework?
It is homework. It is homework. All of it.
cool, thank you.
It won't be due next day, but it'll be due shortly after that. Where did it go? so sorry to have to do this to you.